Thank you, Dr. Hillman, for a very sobering and I hope inspiring presentation, too, a call to action for all of us. Moving on to the last topic presentation this morning in our plenaries, I'd like to introduce Dr. Babak Kateb. Dr. Kateb is the founding chairman of the Society for Brain Mapping and Therapeutics and the Brain Mapping Foundation, the scientific director of the Society for Brain Mapping and Therapeutics and Brain Mapping Foundation, the director of the National Center of Nanobioelectronics, the director of Brain Technology and Innovation Park, and CEO of Smart Microscopy Elocution Lessons, Smart Microscopy, Inc. Dr. Kateb is going to be here to tell us a great deal about the insights that he has acquired in neuroscience and neurosurgery that comes from the technology that has been developed through NASA programs. I'm very excited to hear the next presentation. Dr. Kateb.
Thank you. Thank you. Good morning, everyone. It's a great pleasure and honor to be here, and I want to actually acknowledge the organizing committee and Dr. Manish and Dr. Jennifer Fogarty, and for those of NASA scientists and civil servants who have come to work and helped this country to move forward. I think we owe them a round of applause. So today I'm going to talk about the application of basically NASA technologies in neuroscience, and we will have a fun journey together through several videos and discussion points to see how the technologies that you are actually developing can help us address some of the challenges in clinical neuroscience and neurosurgery. So this is a disclosure about a technology that we developed in partnership with NASA JPL, and basically I was a visiting research scientist there for 15 years, and you could see, if you can run this video, one of the challenges in neurosurgery is to how do you identify tumors while you're operating. So this is a skull-based case that was done several years ago, and you could see that it is very difficult to find where the tumor is. So I don't know if you have a sound on that. So as you can see, this is a tumor right here, and this is a 14-hour surgery at the middle of someone's brain. But it is very difficult to differentiate between normal cells and brain tumor cells, and that's basically one of the challenges that we had about 15 years ago, and we have now moved forward to introduce new technologies to address that. So the learning objective of today is to give you kind of an overview of what the Society for Brain Mapping is, how we actually started, and the Brain Mapping Foundation, and how they have impacted translational policies like Obama's Brain Initiative, which I was heavily involved with that initiative, and the G20 Neuroscience 20 Initiative, and Brain Technology Innovation Park, which is a $120 million California state and $120 million federal government initiative. I hope that government opens up pretty quickly. And then define some of the definitions of like brain mapping, what is the nanoneuroscience, what is nanobioelectronics, and give you some examples. So with that, I want to say brain mapping is not only brain imaging. So if you can please run that link for us. So we can define brain mapping as like a Google map, and you will, so. The foundation is basically a 501c3 charitable organization that actually raises funding to support a group of multi-specialty scientists who are from different backgrounds. coming together under the society umbrella, which is the medical association. So annually we bring them together in a World Congress for Brain Mapping. These are the scientists of different backgrounds, physicists and electrical engineers, neurosurgeons, radiologists, neurologists, stem cell scientists, nanotechnologists. They usually don't cross paths. They go to their own conferences. So we try to actually bring them all together and help them to interact and cross-pollinate ideas.
You can't just keep looking at everything as a single part. What you need to do is look at it across all these fields. In addition, the organization isn't just about therapies, it's also about understanding fundamentally the brain.
The brain is really what distinguishes human beings from all other animals, and it's the huge size of our brain that's important. And the way the brain has evolved over the last, say, 6 million years that differentiates us from the greater apes has led to several of the problems that I think that we have uniquely as humans.
We can now do things that we only dreamed about 10 years ago. So that's the technology and the engineering that's the basis for different and new technologies is what gives us the power to look at the brain in new ways. So it really plays a huge role in terms of our understanding of the brain and our understanding of the functions of the brain.
And you need a particular set of defined targets that you can approach and problems that you can solve. And after that, it lifts the field enough that you can go for even more meaningful targets.
I think what strikes me more than anything else about the organization is the commitment to integrate the various different sciences and the engineering aspects in a way that really delivers capability, medical capability, in probably the most urgent area that we have in the wars that we're fighting right now. The traumatic brain injuries and post-traumatic stress issues are issues that we don't understand very well. I'm convinced after being here just a couple of days that time matters, and I worry a great deal about solutions which might be here to some degree now that we need to move out as rapidly as possible. So if we're going to focus on a gap, I think one is probably a time gap that we need to move them as rapidly as possible, and the delays that I worry about is the emergence of symptoms tied to these injuries 10, 20, 30, 40, 50 years from now that we might be able to mitigate or even eliminate with the kind of both technology and integration and from the neuroscience to the bioscience to the engineering aspects of what this conference and what this organization brings. So I'm very encouraged, and I'd like military medicine to be very much plugged in to what's going on here.
This is what I'm sure of, is that we're understanding the brain better and better and better because we can map it better and better and better, and we're developing new technologies to interact with the brain in a less and less invasive way. And just this ultimate frontier, it's just virgin forest waiting to be explored. And I think you're going to find just a whole gamut of cool concepts, technologies, treatments, therapies that let us expand our knowledge of the brain and treat diseases that have never been addressed before.
With some 100 billion neurons and up to 1,000 trillion neural connections in the brain, the only way we'll be able to tackle this great challenge and maximize the immense opportunity is through international partnerships like the G20 World Brain Mapping and Therapeutics Initiative. Congratulations to the National Center for Nanobioelectronics, the Society for Brain Mapping and Therapeutics, and the Brain Mapping Foundation for pushing this effort for over 14 years. I want to especially acknowledge the great work done by Drs. Kateb, Filler, and Tarhan.
These things are so inspiring and get people to understand, hey, this is not just a bunch of geeks, it's folks that are really making a difference, and they are really personalities, and they do a lot of good and have fun doing it. So I think it's important to let people know that science is hard work, yes, but the rewards are great, and society needs it.
And so it comes down to understanding, and I think what the society is trying to do is to really attack that problem from a number of different levels. Both the talks I've seen so far here have been a mixture of the basic science. Let's look at the maps. Where are things? How do we figure this out? the computational science, which says how do we analyze that in some reasonable statistical way, and the clinical science, how do we then use this information to make clinical treatment decisions. So I think this is spot on. I mean, I think this is exactly what has to be done, and it's the right way to think about it. And when we fill in all the gaps in the maps, and when we can expand, you pinch out and you can go down to the tiniest level and you can squeeze it in and go up to the top level, and you know where everything is and how they talk to each other. When we have that knowledge, we'll know how to fix these diseases.
So we really need to work hard in this area. This is, to me, the frontier, and I'm going to dedicate my life to it, and I hope everybody in the foundation and societies similarly do so.
Back to the slide. All right, so you have a great understanding of how the society actually start impacting the field by improving the diagnosis and treatment and rehabilitations of patients afflicted with neurological disorders by bringing different scientists together, NASA scientists, scientists from Department of Defense, and so on. So, and we have our annual meeting coming up in March 15. At the LA Convention Center. So we welcome you to participate, and a lot of the funding agencies will be there, and our foundation will be looking at, also partnering with some of you. So in terms of the definition of brain mapping, as I said, brain mapping is like a Google map. You get a snapshot of Earth, you zoom it down to that's an MRI. You zoom it down to cities, that's kind of functional MRI. Zoom down on streets, that's diffusion tensor imaging. And then you basically zoom down on the car. Those are cells. People in the car are basically genomic and nano, basically particles. So having that in mind, we are covering everything from imaging all the way to nanoscale technology. So, and the application of nanotechnology in neuroscience called nano-neuroscience, and therapeutic application of nanotechnology which could enhance neurosurgical treatment is called nano-neurosurgery. So combining nanotechnology with device imaging and let's say AI and other platforms called nanobioelectronic. Nano refers to nano, bio refers to a therapeutic aspect of cellular therapeutics like stem cell, and electronic anything else like AI and imaging. So we do this annual meeting, as I mentioned, and you're more than welcome to participate in March 15 to 17. We have published series of journals out of this convention, and we have published an inaugural textbook of nano-neurosurgery, which was given to President Obama here, and he sent me a thank letter, and also the neurophotonics and brain mapping, which I will talk to you soon. One thing that I want to actually talk to you about here is the importance of getting all of you involved in policy and policy making. You are the best person who understands about the science that you have, but many of you have already been in touch with your congressman, but I think it's time for us as scientists to get involved and be more involved in the science and policy. So I was heavily involved with the Obama's Brain Initiative, and as you can see, I don't miss any opportunity to talk to the former head of NASA and Supreme Court Justice Elena Kagan, or any of the congressional leaders. We also started the actually international partnership and started the Australian Brain Initiative. It is a Malaysian Brain Initiative, and then IEEE Brain Initiative, and as well as basically awarding scientists like Stephen Hawkins we raise awareness about ALS. I also brought the head of the director of NIST, National Institute of Standards, which is a Trump appointee, with Congressman Ted Lieu, who is a Democrat, in our conference to basically have a three-way handshake focusing on pushing science forward in a bipartisan way. So it's very important for all of you to get involved in policy and talk to your congressman, tell them about what you're doing and the importance of supporting science and scientists and science-based policy. So based on this kind of a thought process, we actually started looking at the cost of neurological disorders to the world economy. So at the G20 summit in 2014, we started a Neuroscience 20, and basically at the Innovation 20, we started putting together a global consortium of scientists of different backgrounds together, and annually we have held conferences with G20, and here I'm with the President of European Union Council. We were talking about a new initiative we have in Global Consortium for Neuroscience in Argentina this year. So we published this paper about the Neuroscience 20 on the policy, but it's basically comes down to 3 points. Formation of a national data repository and analysis for neuroscience, and creating a national network of brain bank to provide the best viable tissue to neuroscientists, and also create a global alliance for integrating nanotechnology with device imaging and therapeutics, and facilitating introduction of new therapeutics and diagnostics through partnership with investment funds, private equity funds, and basically venture philanthropies, which will happen in our World Congress in Los Angeles. So again, here are some of the guidelines we have put together for building a consortium and a global, create a global harmonization of the related policies, and bringing all the initiatives together, and look at the neurological cost to the world economy and each economy, and create a very customized initiative for them, and facilitate translation of and commercialization of neurotechnology. So we are working with NASA's headquarters and national labs. We are trying to actually bring some of their technologies to neurosurgery and neuroscience, and engaging some of the private equity funds and VCs to facilitate that. So, and also unifying global regulations and guidelines, and global partnerships. So we start to write a legislation on creating a first brain technology innovation park, I would say, in the world. And basically the aim of this park is, like any other biotech park, is focused on translation commercialization of neurotechnologies. So we would like to actually shorten the time of getting a product approved through FDA in the US, but also wanted to actually basically reduce this cost of getting product to market, and basically by shortening the time of integration, translation, and commercialization through this biotech park in Los Angeles. So, and this will actually help us, the funding that we are proposing is actually going to help to cover the value of death. So many of you have done a tremendous amount of work and scientific work, but when you want to get it to actual market, there is no vehicle to do that. So, and again, it really, it is important to look at the cost of neurological disorders to the US economy, and this is a breakdown slide that you can see is basically, it's cost US economy billions of dollars, so it's better for us to invest in commercialization of neurotech than just take, you know, kind of measures after the fact. So the society basically started in 2004, and the Brain Mapping Foundation started to 2004 at the same time to actually help wounded warriors and veterans with traumatic brain injury and other neurological disorders. And then now we have the basically the G20 International Partnership and the Brain Technology Park. And the idea is to actually basically create an ecosystem of partnership with national labs and with the NASA and the federal labs, and also with universities and nonprofit organizations to fast-track therapeutics. So this is a two-phase strategy that we're showing to you here. And basically, it's going to be started hopefully from next year, a virtual ecosystem of scientific collaborations, and then basically network of life sciences that come together and achieve the vision. So the park is going to be located in the greater Los Angeles area, but also will be basically a hub for, as I said, a partnership for a different type of services that could be provided to scientists, like how do you write your slide deck, or how do you put a business plan together, and so on. And these are all practiced in our World Congress in about 50 days from now. So, basically, the goal of the park is to fast-tracking and funding the translational research and technologies that's coming out of the federal labs and national labs. So I'm going to quickly go over some of those technologies that we actually use from NASA to address some of the challenges in neurosurgery. So if you're looking at here, I want you to pay attention to the UV spectrum wavelength, and also infrared and microwave. So we have used such technologies to actually design a microwave device to actually microwave brain cancer and create lesions to be able to actually minimally treat brain cancer. So
microwave with a chokehold, and can create actually a lesion.
This is a device that was FDA approved with microwave ablation.
Computer, any laptop, and the plan is that at the time of a biopsy, we basically put the biopsy needle out and put the microwave ablation in, and basically ablate the brain tumor.
So it's as simple as a biopsy. Instead of radiating brain tumor, you actually microwave it, cook it. So the other technology that we used is from Shuttle. Basically, it's a carbon nanotube. We functionalized it and put a siRNA around it and activated basically macrophages. These are live human macrophages, and put them back to the, if this is going to, okay. Put them back to the tumor cavity, and we could see that these macrophages, they actually attack brain cancer. So that's a combination of cellular therapeutics and nanotechnology. Well, this is another nano platform we have published in Nature Scientific Report. Basically, we used electroporation and try to actually navigate cells that are implanted to the brain. And in this case, in the mice model here, you can actually track a cell, like a stem cell. If you're implanting a stem cell, you can actually track them where they are. And then this is also in the monkey model that you could actually see where the stem cells are going. So one of the challenges that you have in cellular therapy and stem cell therapy is to actually monitor the movement of these cells, across the nervous system, and always FDA asks you, okay, well, how do you know where they are going to the place that you intend to go? So, and this is one of the nano platform that could be actually used for that purpose. The other nano platform we have is a nano prodrug, which basically two spacers with alpha tocopherol and ibuprofen. Alpha tocopherol is antioxidant and ibuprofen is anti-inflammatory. So the idea here is that you not only tag them with CIS5, so you can actually again use it for cellular tracking, but also you could use it for all types of drug delivery for traumatic brain injury and stroke and Alzheimer's. So imagine in the future, if somebody gets to a car accident, paramedics give them an injection of a nano drug that goes to the area of injury. Like here you can see in the area of traumatic brain injury, and reduce inflammation, increased oxygenation, that expands your golden hours to get to the ER and survive. So another example of technologies, neuroengineering technologies that we have also used from NASA is electronic nose. We actually use the electronic nose that you use in International Space Center to sniff cancer. It turns out that actually cancer smells differently. So we published this in Neuroimage and was awarded by NASA. This brings me almost to the end of my talk. We're almost there, but I wanted to show you some of the infrared technologies that we use for intraoperative brain mapping for can run this. Yeah, so this is a metastatic brain tumor, and it's basically a melanoma. It's a skin cancer to the brain. You could also see that the second video runs. Here we go. So this is the same case in infrared. So it is very important to delineate the margin of tumors and to be able to take them out. So we have done this and with infrared and also ultraviolet imaging, and also use the also use the virtual reality, augmented reality here. I'm not sure if we can run that video, but okay. So the idea here is to actually bring all the different imaging modalities together here and use different spectral imaging. And we know that brain's tumor cells, they have a different optical signatures. So we have developed a technique to be able to actually detect where the tumor is. So on the, if the video shows. Okay, here we go. So here is very difficult to see where the tumor is, but using neurophotonics and optical imaging, you could actually see now where the tumor is and remove that. So, and also we have used the mathematical modeling for predictive modeling, and basically put all this together and use NASA technology, as you can see, that you use for space exploration for intraoperative brain mapping and brain surgery. So with that, I think I want to say, don't be just a scientist. It's great to be a scientist, but you need to be science advocate. You need to spend your time not only in the lab, but also talk to policymakers. We are in a different time, and I think it is important for all of us as scientists to know who is our congressman, who is our senator, who is our assemblyman, and sit down with them, talk to them, invite them to your lab. It is very important to have a science, policy back to it, science, sound science. And the other aspects of this is that you would think it is very difficult to get into to writing policies, but believe me, you know the science, you know what needs to be written into policies, and don't be shy away. Go talk to your congressman, go talk to your senator. They have healthcare policy advisors and science advisors, and you can talk to them and translate your ideas to life-saving policies. And also, as I showed you, I believe that integration of nanotechnology with AI device and cellular therapeutics will be really the next frontier in exploring the brain and spine, and also helping us as scientists to introduce new diagnostics and therapeutics. And also, I think discovery in this area is only possible by collaboration and crossing disciplines. It makes no sense if stem cell scientists are only talking to stem cell scientists. At this time, we need to go out of our comfort zone and talk to NASA scientists, talk to neurologists, neurosurgeons, molecular biologists, and bring them together in our team. And the final announcement is that, again, you're more than welcome to submit your abstracts to World Congress for Brain Mapping and Therapeutics. It's on March 15 through 17, basically Friday, Saturday, Sunday. And we have a short video to invite you to this conference. If you don't mind, run that video link for us. Can you run that video link? So.
Generally, conferences are more singularly focused. You'll have more brain-specific conferences and then, conversely, more spine conferences. But I think the SBMT has done an outstanding job of merging the two.
The uniqueness of this organization is the bringing together of diverse individuals working in all different fields. You'll see materials scientists and physicists and economists, as well as the neurologists and neurosurgeons, neuropsychologists, radiologists, all these different people brought together in one space, in one venue. This is what's unique.
It's an incredible organization. I've come every year that I've been able to, and the posters you learn from, the people you learn from, and Babak's vision for what he wants to accomplish in the future is extraordinary.
Our goal is to create an environment that fosters collaboration. We want new ideas, we want out-of-the-box solutions, really break boundaries around the treatment of our patients with neurological disease. So the Society of Brain Mapping and Therapeutics is the platform that can help that to happen.
So the final thought is that I've gone through a lot of your challenges upstairs, and I've seen a lot of you are interested to get in touch with scientists of different disciplines or clinicians. We are a 5,000 member organization worldwide, and if we can help you either find any answers to those challenges or provide you with support, we will be delighted to do that. So thank you very much for your time, and it's a great honor to be here. Thank you.